Howdy! In this video, we're going to look at simplifying expressions with rational exponents. So we're going to apply multiple different exponent rules here. So in this first example, we have a to the 1/3 times a to the 7/3. The rules are the same whether you have integer exponents or rational exponents. With that being, if you have the same base and you are multiplying two different factors with different exponents or the same exponent, you're going to add those exponents. So this would be equivalent to a to the 1/3 plus 7/3. And since those do already have a common denominator, we can just go ahead and add them. That becomes a to the 8/3. And we could leave it just like that, or if you wanted to convert it to a root or something, you could. You could always do that. Now in this next example, we're gonna scooch this on up a little bit. There we go. We have a to the 2/3 times a to the 7/5, all divided by a to the 3/5. So the order you do all this in doesn't really matter. I'm going to go one step at a time. So I'm going to first combine the two in the numerator by adding those exponents. So we're going to have a to the 2/5 plus 7/5, all divided by, let's recopy that denominator, a to the 3/5. Now we can add those exponents. 2/5 plus 7/5 does make 9/5. And that's over a to the 3/5. And now we have a different exponent in the numerator and denominator, and we are dividing, same base though, a and a, right? So we would subtract those exponents by exponent rules. So that's a to the 9/5 minus 3/5. It's the numerator minus denominator. Luckily, we have a common denominator already. That's supposed to say a 3. Let's try to clean that up. There we go. We have a common denominator, so we can go ahead and subtract those. So 9/5 minus 3/5, 9 minus 3 does make 6/5 for that example. All right, and next we have a cubed b to the 4th, all to the power of 3/2. So a and b are different, right? But so we cannot combine those. But what we could do is distribute that 3/2. Every factor inside of those parentheses, since they're multiplied, a and b are multiplied here, is to the power of 3/2. So we can write that step 1 as a cubed to the power of 3/2 times b to the 4th to the power of 3/2. And then to simplify each of those by exponent rules, we do multiply. So we're going to do 3 times 3/2, which would be 9/2, and 4 times 3/2 would be 12/2. Of course, we can simplify those just a little bit here. So that's a to the 9/2 times, oops, that was not an a, that one's a b, b to the 12/2 there, you're probably wondering. There we go, times b to the power of 6, and that would be a fully simplified answer right there. And we're going to do one more challenge question here to see if we've really got it. So again, make sure you're pausing the video in between each example, and let's give it a try. So we have 2x to the 3/4 over y to the 1/3 all cubed times y to the 4th over x to the -1/2. So just kind of looking at the overall picture here, we've got a number, a constant. We've got x's in the first fraction in the numerator, some x's in the second fraction in the denominator, y's in the second numerator, and y's in the first denominator. So how can we combine all these things? Well, one step at a time. Don't try to do it all in your head in one step. That's a little much. So let's see. And the order in which you do these things in doesn't really matter. You can do it your own way. And as long as we get to the same place in the end, it's fine. So what I'm going to do, though, is I think I'm going to cube everything in this first fraction. We cube the numerator and denominator, and exponents do apply over multiplication and division. So everything gets cubed, right? So 2 cubed would be 8. Then we have x to the 3/4 cubed. You can write x to the 3/4 cubed, which is what I did up here, or you can go ahead and multiply all in one step. 3/4 times 3 makes 9/4, all over y to the 1/3 times 3 is 1. So that's just over y. And now you could bring the x to the -1/2 up to the numerator, or you can leave it. It really doesn't matter. I think I'll go ahead and bring it up though. Why not? So we'll have y to the 4th times x to the +1/2. And you can put it over 1 if you want, or you can just not. Either way, same thing. Now we're multiplying fractions. So we're going to multiply those numerators together and multiply the denominators. So multiplying numerators, the only constant we have is 8. I have x to the 9/4 times this x to the 1/2. So we would add those exponents. I don't really want to do that just yet, so I'm going to just write 9/4 plus 1/2, and I'll figure that out in a moment because I want to stay focused on the big picture here, which is multiplying those numerators. So I don't want to forget my y to the 4th, and that is all over this y times 1. Let's try that again. There we go, y times 1. And so two more things we can do. We can combine the y's, and we also need to simplify this exponent. And then sometimes you may need to go do a little scratch work, like here, right? So 9/4 plus 1/2. Well, 1/2, let's get a common denominator. That is 2/4. So that is going to be 11/4. Okay. So bringing that back over here becomes 8 times x to the power of 11/4 times y to the 4th over y. One of those y's cancels, or we can subtract exponents. 4 minus 1, there's an implied exponent of 1 there, that is 3. So we do get 8x to the 11/4 times y cubed.